more trig derivatives. Sine and cosine we just covered. So now we're thinking, okay, well, what about the other four? The tangent x, and then the secant, cosecant, and cotangent x. And what we can do with each of them is write them in terms of sine and cosine. So now that we know the derivatives of sine and cosine, we can do the rest of them with just converting them using trig identities into sines and cosines. So I'll show you what I mean with tangent x. We know, or you should remember, that tangent x is sine x over cosine x. So then to take the derivative of that, I'm going to use the quotient rule. So it's the bottom function, which is cosine x, multiplied by the derivative of the top function. The derivative of sine x is cosine x. Then it's minus the top function, which is sine x, multiplied by the derivative of the bottom function. The bottom function is cosine, so its derivative is sine. And then it's all divided by the bottom squared. And then we can simplify this a little bit. Cosine times cosine is cosine squared x. Minus sine x times minus sine x gives me a positive sine squared x. All over cosine squared x. And then if you remember, this whole thing, cosine squared plus sine squared x, is 1. So we have 1 over cosine squared x. And then finally we write that as secant squared x. So our derivative, if y is tan x, y prime is secant squared x. So the derivative of tangent x is secant squared x. Okay? And you might remember that there are pairs of trig functions. So cosine and sine, remember, have an identity that links them. So we say they're dating, or there's a relationship between them. Tangent has that with secant squared. You remember 1 plus tangent squared is secant squared. And then finally 1 plus cotangent squared x is cosecant squared x. So we expect that tangent and secant are going to kind of hang out together. Their derivatives are, because sine and cosine's derivatives did, and also we're going to expect that cotangent and cosecant are going to have similar patterns. So they're going to have each other in their derivatives. So if we have tan x, secant squared x. Okay? If you look at secant x, we can write that as 1 over cosine x. And then we take the derivative. So what I'd like you to do, pause the video and try to get the derivative of cosine x by yourself. So hopefully you've worked that out. And now we'll go and write this. I'm just going to write this as, before I write y prime actually, just y is equal to cosine x to the minus 1, right? If we just flip that up. So then y prime becomes minus cosine x multiplied, sorry, minus cosine x to minus 2 multiplied by its derivative, and the derivative of cosine is negative sine x. So what happens is we end up with this negative and this negative canceling, and we end up with this, sine x on the top and cosine squared x on the bottom. And all I'm going to do is write that as sine x over cosine x and 1 over cosine x. Okay? And then the 1 over cosine x is secant x, and the sine x over cosine x is tangent x. So our conclusion is that if y is equal to secant x, the derivative of that, y prime, is secant x tangent x. All right? And for the sake of the time in the video, because I think I'm going to run out if I don't, because I want to do some examples as well, I'm just going to show you the other ones, or say what they are. You can prove them. That's 2 out of the 4. So cosecant, you would do 1 over sine x, and y prime will eventually become minus cosecant x cotangent x. If you want to follow the proof, it's exactly the same as the proof for secant. And I would, encourage you to do that, but you end up with this as a result. So the derivative of cosecant x is negative cosecant x cotangent x, and for cotangent, you would write it as cosine x over sine x, and then it follows exactly the same pattern as tangent x. And what you end up with is that y prime is negative cosecant squared x. Okay? So just sort of as a summary, if we kind of make a table, if y is there and y prime is here, we have tan x, the derivative of that is secant squared x. We have secant x, the derivative of secant x is secant x tangent x. We have cosecant x, and its derivative is negative cosecant x cotangent x. And finally, the derivative of cotangent x is negative cosecant squared x. Okay, so those are the derivatives, and they're very much like the power rule in the sense that they actually change the function, right? So with the power rule, we said, if it's 3x squared, this power rule actually changes to 2x to the 1. When we do the derivative, it actually makes a physical change to the function. These do as well. And if you want to add in, because we did them in the previous video, sine x, the derivative that's cosine x, and cosine x, the derivative that's negative sine x. So that's all 6 of your trig functions all in one table, if that's helpful to you. But they actually physically change the function. So all we're going to do, using the same rules that we used before, but with new trig functions, we're going to take some derivatives. So we'll just practice a few of them, and then I'll let you practice some on your own. So first of all, that 3 is really saying this. Okay, so we have to deal with the 3 first. So we're going to go 3 cotangent squared of this. That's our first step. Then we've dealt with the 3. Then we have to deal with the cotangent, because it's cotangent of something squared. So the cotangent, the derivative of cotangent, you remember, is negative cosecant squared. So now we've dealt with the cotangent. Then we got to deal with the derivative of this. The derivative of this starts with the power. So we do 2 times 1 minus 2x to the 1. Then we've dealt with that. And so finally, we just have 1 minus 2x. The derivative of that is minus 2. Okay, so there's our derivative. And if you want to simplify it a little bit, you can multiply minus 2, 2, and 3, and minus 1, and end up with 12. And the rest of it really doesn't simplify. So hopefully you see how that works. But we're still using the chain rule. We're still using power rules and those sort of things. It's just we have these new functions to deal with, all right? So here's another one. I have y equals 1 over the square root of secant 2x minus 1 all cubed. So what I'm going to do before I do anything with that in terms of derivative is I'm going to simplify it by writing this as 3 over 2, 3 here, half there, and then negative because it's in the denominator. So y prime is going to be minus 3 over 2. It's a power rule first. Secant 2x minus 1 multiplied, not multiplied, but raised to the minus 5 over 2 because I'm subtracting 1. And then the derivative of secant 2x, derivative of secant is secant tangent of whatever the angle or the argument happens to be. In this case, it's 2x, and then multiplied by the derivative of the 2x, which is 2. Okay, and then the derivative of minus 1 is 0. So there's my answer. That's how you do it. Okay, with this guy, well, power first, right? So we do this power first. We go minus 3 tan of x squared minus x to the minus 2 minus 4. Then we multiply by the derivative of what's inside. What's inside is a tangent. So the derivative of tangent is secant squared of whatever. So x squared minus x to the minus 2. Then we multiply by the derivative of the x squared minus x to the minus 2. So that's minus 2 onto x squared minus x to the minus 3. And then we multiply by the derivative of the x squared minus x, and that's 2x minus 1. So there's our derivative. Big long thing. That's how you do it. So hopefully that's making sense. I don't want to overwhelm you in terms of material, but what I'd like you to try to do is kind of pause the video, take the derivative yourself, see if you can get it, and then go on from there. So here's another one. This one's huge, so I'm not going to expect you to do it all. But you'll notice there's a quotient rule, and then there's another quotient rule, and there's all this stuff. Biggest thing that's going on is this. It's the quotient rule. So you have to take the derivative of the quotient rule. I'll just show this to you just so you can appreciate the beauty of it. But not going to expect you to do that. But there's your derivative, and I didn't even finish. So there you go. I got bored, I guess. But I would like you on Tuesday, we're going to do some questions in class to do with sine, cosine, tangent, secant, cosecant, and cotangent derivatives. So as long as you understand the concept of what those derivatives are, and yes, you are going to have to memorize them because I'm just a mean person, all right? So you do need to know them. And then on Tuesday during class, we'll actually do some questions.